Hello, okay, I'm going to go through the homework corrections of question 14 from last night. So this was quite a difficult question. We had a sign hanging on a wall. Now the diagram as it's given in the book shows a brick wall. I'm just going to do a straight line for the wall and the sign coming out of it from it like this. And it's really the bar, the metal bar that the sign is hanging on, that we're interested in. The rest of it doesn't really matter because we're not doing anything with that. The sign is hanging like that. And the diagram has filled in some information. It says that there are two wires attached to the wall. Okay, so my flat wall like this has the points B and C directly across from each other. Let's do C like that. And the halfway point here, D. So the wires are coming to the end of the pole like this, supporting my sign. Now, some other information. They tell us that the length of this pole that the sign is hanging on is 120 centimeters. Okay, so we'll be using some triangles with that, and that the distance from where the pole joins the wall to this point D here is also 120 centimeters. Okay, so this is quite difficult to visualize. We've got our flat wall back here and two wires coming out from it then. We're also told that the distance between the joined points is 100 centimeters, 50 to D and then 50 to C. So that's those distances there are exactly the same. Okay, the first thing we're asked to do is to calculate, this is the point A down here, we're asked to calculate the distance from D to A. And if we want to do that, what we really want to do is find a right-angled triangle that DA is included in. So I hope that it's clear enough that because this is a wall, a straight vertical wall like this, and I've got a pole coming straight out from it, the pole makes a right angle with the wall. So it's very hard to see it on the diagram, but that is a right angle. So when I join D to A, I'm making a right-angled triangle with the pole that's coming out from the wall, like that. So the first triangle I want to sketch out, and let's just call this the point P. I don't think there was a point. No, it's E. It's E on the diagram. So D, E, coming down like this. We have A, and we know E to A is 120 centimeters because we're told that. We have a right angle here, and we know E to D is 120 centimeters because we're told that as well. So this should be an isosceles triangle, even though I haven't drawn it as isosceles, and I can use Pythagoras' theorem. That's the hypotenuse that I'm looking for. H squared is 120 squared plus 120 squared, and H is the square root of 120 squared plus 120 squared. Be careful, you know that's not 240 squared. We have to square it before we add them. And that gives me 120 squared plus 120 squared. It actually should be 2 times the square root of 120. Let me just check what they ask for in the answer. Okay, it doesn't say, we'll go to 2 decimal places, so 169.71. So that is 169.71 centimeters to 2 decimal places. Or if you left it in third form, it would be 120 times the square root of 2. You can just verify that that's the same thing. So 120 times the square root of 2. And that is exactly the same answer. Okay, so hopefully that one was accessible enough. The next question we're asked to do is to calculate the length of each wire. Now, we have a triangle coming across like this, which is an isosceles triangle, and we know its base, and we know its perpendicular height, because we know the distance from A to D. So if I'm to sketch that out, just to show you what I mean, I have a triangle like this. B to C along the bottom is 100 centimeters. The midpoint there is D, and A at the top. And we've just calculated what D to A is. We did that in the first part. So we know that that is 169.71. I have two equal right-angled triangles because that's an isosceles triangle. So if I just investigate one of those, B, D, A, 169.71 and 50, I can use Pythagoras' theorem to find the hypotenuse. And that is that h squared is equal to 50 squared plus 169.71 squared. So h is the square root of those 69.71 squared. We'll put that into our calculator in one go. We get plus 169.71 squared. And that's 176.92. 176.92 centimeters. That's my second answer. Let me just check the format that they asked for the answer in. Correct to the nearest centimeter. So I won't leave my answer like that. That's approximately 177 centimeters. So my answer to part 1, 169.71, and my answer to part 2, 177 centimeters. Okay. Part 3. Find the angle that the wire AB makes with the wall to the nearest degree. So, what are we being asked for here? Let's look at our diagram. We have AB like this, and let's just join B to E and talk about this triangle here. What are they asking for? Are they asking for the angle in here, my flat triangle at the top? Or are they asking for the angle in here, where this is my triangle coming out from the wall? So let's consider our wall again, okay? Our wall up like this, and we have a wire, and it's not even coming straight out, it's coming out at an angle like this. They want the angle that it makes with the wall, okay? And there's two ways of interpreting this. So it was a badly asked question, and I will accept either answer that you give. But I think what they want, so the wires coming down like this. Let's see this away. Use a different color. The wires coming down like this. Okay, so let's turn this over. We want the angle that's in here that the wire is making with the wall. But it's ambiguous, and it was a pre-paper question. So if you found the angle ABC, I would give you the marks for that, but what they actually want is the angle ABE. So part 3, they're asking for the angle that the wire AB makes with the wall. And it makes the angle ABE with the wall. Okay, so that's what we're actually being asked to do. Now, I'm not sure if you can visualize this, but this triangle, when I join A to B and B to E, this is a right-angled triangle. Why? Because the wall is completely flat and this is a right-angled triangle, ABE, because the wall is completely flat and the pole is coming straight out from it. So this is the triangle that we want to sketch out. B to E, down like this. And then A over here. So that's a right angle triangle, and this is the angle that we're trying to find. Now, what information do we have? Well, we know this distance here because we're told it, that's 120, and we know this distance here, AB, because we just found it, the length of the wire. We just found it in the last part. So we can use, we're looking for an angle in a right angle triangle, we're going to use SOHCAHTOA. This is the opposite side, this is the hypotenuse, it's the longest side, that's the adjacent, which we're not using. So we're using opposite and hypotenuse, and sine of B, opposite over hypotenuse, which is 120 over 177. And B is sine inverse of 120 over 177. So B is sine inverse of 120 over 177. And that is 42.68 degrees. And the question asked for us to give it to the nearest degree, so that's approximately 43 degrees. Okay, now I would consider that probably as difficult as these three-dimensional problems get. So if you can understand all parts of that question, and if you could do a similar question to that without using your notes, I would say that you can consider that you understand three-dimensional problems. But I do recommend that you take some time over the coming weeks, months, maybe even next year a bit, to look through the other 3D problems in the book. And of course, we'll look at some exam paper questions at the end of this as well. Okay, thank you very much.